Hi, welcome back from spring break, guys. Hi. 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 So we're working on 10:7. We're continuing on our chapter for circles. Today's conversation are the special segments in a circle. Sorry, I forgot how to write because spring break. Special segments in a circle. Today is March the 18th, and you're my fabulous 8th period class. Whoop, whoop. Before we get into the first big theorem today, let's clear up a new vocabulary word. This word is chord segment. A chord segment gets created when two chords intersect inside of a circle. And the picture looks something like this. Okay? And so each one of these little pieces right here are a different chord segment. Okay? So that piece right there is a chord segment. And this little piece right here is a chord segment. And this little piece right here is a chord segment. And this little piece right here is a chord segment. Okay? So each one of these little pieces of a chord are chord segments. This gives us our first theorem called the chord segment theorem. Chord segment theorem says this. If two chords intersect inside a circle, meaning it looks like this. I draw with different colors. Then something's going to happen. Okay. I'm going to reduce the amount of words that these theorems have because they get wordy really fast. It says, then the products of each of those chord segments are equal to each other. Okay? So I'm going to take each of these chord segments. This is a chord segment. We're going to multiply them together. So I need some letters, please. Can I have 5 different letters from 5 different people in the room, please? C. E. Z, F, J. All right. So one chord segment could be this one right here, J to Z. And each of these are chord segments, but I need you to watch carefully as to which segments are getting used. Okay? These two chord segments on the same side of the equal sign, they're on the same chord. Do you notice? This chord segment is this piece, and this segment is this piece. It's the same segment. Okay, it's the same chord. Then this other segment, this other chord, is here. Okay, do you notice how on this side it's the other chord segment? The other chord that we're talking about? Okay. That's the hard part about this theorem, is making sure that you're grabbing things on the same chord to multiply together. Okay. All right, when you're ready, join me on the top of your notes practice page. Okay. I'll switch over in about 5 seconds. I put up some of the words on the one I'm doing for you guys. Okay? Bless you. I'm just labeling here for you. Okay, just making that really clear that we're doing chord segments times chord segment, and that those chord segments have to be on the same chord. Okay, the same line across the circle. Okay. Give me a thumbs up when you're done copying. And you're feeling comfortable with it. Thank you. Thank you, thank you, thank you. Are you done copying? You've digested? I know that you're not copying, you're kind of reading off of the prepared notes, but make sure that this is making sense next to what we're doing. Okay, because we're going to go on to the practice page to apply this, and I want you to be ready for it. Do you need a pencil or a pen? I don't see anything. Yeah, get it right instead. Ready? Yes, 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 and yes. Good. All right. Your choice between 1 through 4. Which one looks the most concerning? I think I want to stick to 1 and 2 for now. Number 2? Number 2. All right, we'll do number 2 together. All right, is this a 2 chords intersecting inside of a circle thing?
Yes.
Yes. Okay, so that means that our formula says that we're going to take the 2 chord segments on one chord, multiply them, and they'll be equal to the 2 chord segments on the other chord. So here's one chord segment. Here's the other. Okay, now on the other chord, here's one chord segment. And then here's the other. Okay, did you see the setup? Making sure that you're on the same chord, on the same side of the equal sign. All right, x times x gets written as? Not 2x. 2x means 2 times x.
X squared.
X squared. X times x is x squared. 2 times 10 is? I want the value of x. I want the number that you multiply to itself, and it gives me 20. How do I undo a square power? Take the square root. Again, how do I undo a square power? Take the square root. So x equals whatever I get when I do the square root of 20. And since my directions say round to the nearest tenth if necessary, you can go to your calculator and type in square root 20 and have it spit out a decimal. 4.47. Now wants me to round to the nearest tenth. What decimal place is the tenths? The first one. So I'm going to round to here, which means I'm going to look where? To the 7. And is the 7 big enough to make me round up?
Yes.
Yes. So then I'm going to round it to? Beautiful. And that's your final answer. All right. When you're ready, join me back on our notes page. Yes? All right. We have another new vocabulary word for you today. this word is the secant segment. The secant segment is a segment of a secant where one endpoint is on the circle, but only one of those endpoints is on the circle. Okay, so let's draw this and let's figure out what this means. All right, I have a circle, and I need a secant line. What's a secant line? Mm-hmm. A line cutting the C? A line cut in a C. It does cut a circle, and a circle starts with C, so I can see that. Yeah, that works. Yeah, so I can cut the circle, and it kind of makes like a letter C right here. Ethan, look, kind of makes your C right here. All right, so there's your line. It cuts a circle in two spots. Now, the segment of this secant line, that means there's a piece of a segment here, a piece of a line, so it's going to have two endpoints. One is on the circle, and the other one is not on the circle, meaning that it's somewhere outside of it. Okay? You can't have the secant segment stop somewhere in the middle of the circle because it hasn't crossed the circle in two places, and it needs to be considered a secant. All right, so far so good? We've got a special name for this part of our secant segments, the part that's hanging out outside of the circle. This part is called the external secant segment because it's the part outside of the circle. Ready for our next theorem? This theorem is called the secant segment theorem. It says this. If two secants intersect outside a circle, all right, so our setup is we have a circle and we have two secants and they're intersecting somewhere not inside of the circle and not on the circle. All right, let's get some point names going. Can I get 5 point names? 5 different people, maybe 5 who haven't had a chance to say anything yet today.
B.
Did you already say something today? Okay.
L.
Okay.
G.
G. What did you say? L? You've given me 4 letters today. Give someone else a turn. You can tell someone else to tell it. Say P. I heard from over here. P. And then I heard an E.
L.
Alrighty. We should be able to get some more letters soon. Okay. So we have this setup. Here's your formula. Again, we're going to have 2 things multiplying together. But this time, it's going to be the entire secant segment and it's multiplying with its external secant segment. Okay, take a moment to look at that. So the first one is the entire segment, the whole thing. And the one it's multiplying to is just the part of it that's sitting outside of the circle. Okay? And again, that's on one secant segment. I really need you to put your phone away. I really need you paying attention up here. Thank you very much. Okay? And that's going to equal to the same setup, but on the other segment. Okay? So here, again, the entire secant segment multiplied by just the little piece that's sitting outside of it. Okay. Give me a thumbs up when you've got this copied and colored and digested. Head toward, if you're ready, head toward the examples. Head toward the examples when you're ready. And you're going to be looking at the bottom of the page. All right, which examples from the bottom of our practice page from 6 or 9 would you like to see worked on?
9.
Number 9. All right. Do I have two secants intersecting outside of a circle? Yes. Okay, so that means that our formula is two things being multiplied together and those things are equal. The first thing is the entire secant segment. And the second thing is going to be that same secant segment, but just the piece of it that lives outside of the circle. That equals the entire secant segment, the other one, that being multiplied just the piece of it that's outside of the circle. Okay. This is the hard part. Identifying which pieces we're using. Any questions on this one? Make sure you feel comfortable about where I got which piece. All right, I'm going to go ahead and start substituting. Now, VA, the entire length of this, is going to be this piece plus this piece. Okay, so I have to add those two things together. Okay, VR is just 6. Now VP, VB is going to be that piece plus this piece. Okay. VH is just the little piece outside. Are we all right with this? We okay with where I got those numbers? All right, I'm going to do some cleanup, some distribution, some combining like terms, all in the same step. Ask questions. Yes?
Cesar Reina, he's going home.
Thank you. All right, I'm going to distribute on the right. And now I'm going to start collecting things. I'm going to gather all of the X's to one side of the road so that maybe I can call a restraining order on them, because who likes their X's hanging around? And I'm going to shove all the numbers on the other side of the road. All right, getting rid of my X's. I'm going to go ahead and move these numbers over as well. So the numbers on this side go, and the X's disappear there. And I'm left with 18x equals, someone help. 20, 22, 18? I was way off. I'm assuming you had a calculator. Or you just did that in your head because you're awesome. Okay, I totally believe you. X equals 1. Question on the setup. Question on the distribution. The solving felt okay as well. All right, we only have one more theorem to go over, and then we done, guys. All right, when you're ready, join me back over on our note-taking paper. The last theorem is called the secant tangent theorem. Secant tangent theorem says this: if a secant and a tangent intersect outside of a circle, then, all right, let's draw our setup. I have a circle, I have a tangent, and it connects to a secant. And that intersection happens outside. All right, 4 letters from someone who hasn't said anything yet at all today.
B.
A. Have you given a letter yet today? Can I have a letter? B. Have you said a letter yet? R? All right. And Juan, have you said a letter yet? ¿Me das un letter?
Oh,
Which one? A. Ya lo usamos. ¿Me das otro?
J.
J. J. Check? J. Dile. J. Beautiful. Okay. Then, this is the formula. Ready? The formula has a something squared. That something squared is the tangent piece. This piece. Okay, the tangent part. On the other side is going to be the secant segments, like the entire segment, times that external part. Okay. take a moment to make sure that that part of the formula is making sense. Okay, we're going to do one more example with this, and then we're going to call it a day. And then you'll have the last remaining few minutes of class to try to get as many of those 5 questions left as you can. Okay? At the very least, the setup. All right. You're looking at the practice. Number 5 or number 6, your choice. Number 6, no, number 6 is going to be like number 9. Oh, I'm so sorry. Number 5 or number 8. My apologies. Number 5. Okay. So we're going to look at practice number 5. All right. Practice number 5. We have a tangent and we have a secant. There's the tangent. And our formula says that we're going to take the tangent and we're going to square it. And then we're going to take the entire secant segments and we're going to multiply it to just the piece of the secant that's sitting outside of the circle. Okay, time to substitute some values. Go ahead and turn that off. That's... yeah. I must have accidentally changed that without realizing it. I'm so sorry. All right. The entire length of the segment is this piece plus this piece. Okay, so the entire segment, you have to add those. The external part is just this piece right here. All right, I'm going to need help from calculators. 3.3 squared. 10.89. All right, now here I'm going to distribute. 2.2 times x I can do. 2.2 times itself I can't do in my head. I need help. 4.4? That feels odd. 4.84 feels better. Oh, because I already have the answer? I've already done this one like 4 times. All right, now what? Yeah, now I need to get x by itself, so what do I do? Yeah, subtract this thing. Okay, 10.89 minus 4.84. Bueller? I guess it's on you, man. 6.05. And then we need to divide that by 2.2. 2.75. And we've been asked to round to the nearest, which means this decimal place. So it's 2.8. That's it. All right, you guys got just under 20 minutes to get 5 questions done. You got this. Thank you very much.